Be talking about angle pairs. Some of these angle pairs we have seen already in class, and some of the rules are new. We are going to start with some reasons that we might be using in our proofs. The first one is the right angles congruence theorem. The right angles congruence theorem states that all right angles are congruent. Sometimes I will abbreviate this in a proof. If I am using it for a proof, I'll put all RT, angles, and then congruent symbol like that, just to abbreviate it if you don't want to write it all out. You can also call it the right angles congruence theorem if you want to put the title of it. The congruent supplements theorem and the congruent complements theorem are going to be very useful for us in our proofs. They can save you about 5 or 6 steps. In a proof, if you remember this reason, there's always, not always, but there's a lot of the time there's more than one way to do a proof. And the proofs that involve congruent supplements could be, if you forget this rule, you could take a lot longer to get where you're trying to go in your proof. Sorry, that was my alarm. Congruent supplements theorem states that if two angles are supplementary to the same angle, or two congruent angles, like if you have a pair of matching angles, then the angles are congruent. For example, if you know that angle 1 is supplementary to angle 2 and angle 3 is supplementary to angle 2, since they're supplementary to the same angle, that means that those angles themselves must be the same and therefore congruent to each other. The congruent complements theorem is very similar to the congruent supplements theorem. Essentially, write it word for word and then take out the word supplementary and replace it with the word complementary. So if two angles are complementary to the same angle, or two congruent angles, then they are congruent. Complementary means they're adding to 90. So if you have two angles that add to 90, and then one of those can add to 90 with another angle, then those complements will be the same. So if angle 1 and 2 are complementary, and angle 2 and 3 are complementary, since 1 and 3 are both complementary to angle 2, that would make 1 and 3 the same as each other. We saw the linear pair postulate in Unit 1. This is going to be used very frequently in our proofs. Of course, my Apple Pen just died. The linear pair postulate states that if two angles form a linear pair, then they are supplementary. So I'm going to try to get where I can add that. If two angles form a linear pair, then, oops. There is a huge delay in the typing, sorry about that. They are supplementary. So two angles, if they are a linear pair, then they are supplementary. To remember what a linear pair looks like, they are a pair of angles that forms a straight line, and they will be supplementary all the time. We're going to look at a couple of proofs here to practice. We are given that 1 and 4 are congruent. So angle 1 congruent to angle 4. And we are also given that angle 3 is congruent to angle 5. Our goal is to prove that 2 is supplementary to 4. Well, notice that 1 and 4 are congruent. And we can also see that 1 and 2 makes a linear pair, and so do 3 and 4. And so I'm going to be using the congruent supplements theorem to figure out that 2 and 3 are congruent to each other. And I am also going to be using congruent supplements theorem to kind of work to getting 2 and 4 supplementary to each other. All right, so let's start with our given. Generally, we start our proofs with what we are given. 1 is congruent to 4, and 3 is congruent to 5. This was given. We can use angle 5 in here. I didn't mention that a minute ago. Angle 5, it was given as being congruent to angle 3. And we can see in the picture that angle 2 is vertical to angle 5. So we could say that they are vertical angles and they would be congruent. I think I'm going to go with what I call the equation method of working this problem out, because I think it will make more sense if we are using that math and looking at that math and that relationship. So I'm going to add in that we know that 5 and 2 are congruent right here. The reason for that, vertical angles congruent. Vertical angles are congruent there. And since I am going to do some of the math route here, I am going to convert all of these to being the measure. The measure of angle 1 is equal to the measure of angle 4. The measure of 3 is equal to the measure of 5. The measure of 5 is equal to the measure of 2. All of these would be the definition of congruent angles, because we were taking them from congruent to equality. Now let's get some equations going with 1 and 2 and 3 and 4, because they are a linear pair. They are supplementary. So for line 4, I'm going to say angle 1 is supplementary to angle 2, and I'm going to say that angle 3 is supplementary to angle 4. I'm putting these together because it's the same reason for why. This is the linear pair postulate. Since they're supplementary, we could write an equation with them saying the measure of angle 1 plus the measure of angle 2 equals 180. And we can also write the equation measure of 3 plus measure of 4 equals 180. This would be by the definition of supplementary angles. So now I have some math and I have some angle pairs that are matching. If my goal is to say that 2 is supplementary to 4, then what I would really like to do is to replace the measure of 3 with the measure of 2. So let's kind of look at 3 and 2. In my diagram, I have them marked congruent to each other, but I do not have them written congruent to each other in the proof yet. If this happens, if you're looking at your picture and they have that same marking in the image that you had added for that relationship, but they were not already written in the proof, chances are you're going to be using the transitive property to get those linked together. So let's go kind of look at 3 and how we can get that 3 to be a 2. So we see a measure of angle 3 here, and we see a measure of angle, well, that's where we have 3. Here's 3 as well. We're trying to kind of pair these together. We know that 3 is the same as 5 in this equation, and we can see also that 5 is the same as the measure of angle 2. So here's where we've got a transitive property in our proof that we can use to directly link the measure of angle 3 with the measure of angle 2. So I'm going to do that on the next line. Measure of angle 3 equals the measure of angle 2. And this was working through those statements above in line 3. Since we know that 3 is the same as 5 and 5 is the same as 2, we can say that angle 3 and angle 2 are the same. And this is the transitive property and it's an equal sign, so property of equality. Substitution is also acceptable there. And now that I know that 3 and 2 are the same, I can use that statement above, how measure of 3 plus the measure of 4 is 180, and I can replace angle 3 with angle 2. So I'm going to be doing that. I'm going to use the right side over here to kind of continue the proof. Statement number 7 would be to say the measure of angle 2 plus the measure of angle 4 is 180. And the reason for that was substitution. And then our last step, now that we can see that 2 and 4 add to 180, and our goal is to get 2 and 4 to be supplementary, this is what supplementary means, so we're able to now go ahead and say that they are supplementary. And this is by the definition of supplementary angles. So I would say this is a little bit longer version of this proof because I chose to use the math method, going from the phrase supplementary to the equation adding to 180 and using substitution. I could have worked this a different way using congruent supplements theorem, but I feel like, especially at first, that's a little bit more confusing to work through. But we will be practicing some of that on the homework. Let's look at another one. We are given that C is the midpoint of BD and B is the midpoint of AC. So let's see. C is the midpoint of BD. Let's go locate BD. C is the middle of that, meaning these two pieces are congruent. We also have another segment listed. B is the midpoint of AC. So AC here. And that means that BC and AB should have the same marking. And BC already had a marking, so we're going to use that same marking. So now that I have thought through what they're telling me with the definition of midpoint, getting my congruent segments here, I could see that each small piece is equal. Our goal is to prove that AB is congruent to CD, and now that I'm looking at my markings, I agree that they are all the same. Remember what I said earlier in this video was that if you have markings that are the same from reading your given like this, but they weren't directly related in the given, probably you're going to use that transitive property to link those things together, and that's what we're going to be doing, kind of working through that shared segment that each of that AC and BD, they both share BC, so we're going to be kind of working through using that segment in common. So I'm going to go ahead and start by listing my given. C is midpoint of BD, and B is midpoint of AC. When you have vocabulary words in your given, do plan to use the definition of those. The reason for your given is always given. We saw in the image, we looked at it, and we decided if C was the midpoint of BD, that told us that BC is congruent to CD. We also know if B is the midpoint of AC, then AB is congruent to BC. And these were from the definition of the word midpoint. We can see that they have used BC 2 times. And that allows us to link together AB and CD through the use of the transitive property. When you have that matching item and you're basically just mixing and matching the pieces that are equal to get a new statement using the congruencies that you have there. So BC was the one that I like to call the middleman. We're going to take that one out and we're going to link the other two together. CD congruent to AB. That relinking, that transitive property, and the sign is congruent, so we're going to say of congruence. So remember, there is a transitive property of equality and a transitive property of congruence. So I should have thought about this before I wrote this line, but what we're trying to prove at the top there, AB congruent to CD, well, I wrote them on the wrong sides. So I need to switch the sides. You could either erase what you wrote and switch them, or you can add a line here and switch them. This is a good practice anyways. When I'm just taking the things I had and switching the sides, that's symmetric property, and this is a congruent sign, so of congruence. So if you want to switch the sides, because you need it to look just like the prove statement, what they're trying to get you to prove, sometimes you have to switch sides. All right, moving along, this is the last little bit. Here are these top 3 diagrams, and this is just to talk about what we can tell by looking at what's marked in the picture. And to justify our answers, like if we were asked to write this out, we might write reasons like linear pair postulate or congruent supplements theorem, congruent complements theorem. I'm not going to do that. I'm just going to kind of look at each image. So in this image, I have both vertical angles and linear pairs. The 125 label right here, I could pop over here to its vertical angle pair. We can use linear pair postulate and the fact that these two angles here would be supplementary, and 180 minus 125 would be 55 degrees. So that gets us that angle measure, and using vertical angles again, pop over here and you can label that one. So now we know all of the angles in this image by using linear pair postulate and vertical angles congruent and that sort of thing. On number 19, we have some right angle markings. We have a right angle marking here, and we have a right angle marking up here. And what we can know from those two right angle markings, notice that tells me that this angle here and this one here are complementary. And we know that this one here and this one here are complementary. Since they share this angle in those complementary relationships, that means that the other two are going to be congruent to each other through the congruent complements theorem. Since one of these already has an arc mark, we're able to put that arc mark down here. So that is using the congruent complements theorem. We can also look in this picture and we can use the angle congruent markings that we already had. Those angle markings are telling us that those angles are equal to each other. That combined with the right angle marking that I have highlighted there in green tells me that each of those is 45 degrees. Since we already determined that the angle DOE was the same as those two, we can know that that one is 45 degrees. And using the fact that angle AOE is a straight angle, which is comprised of these 4 angles, we could find the remaining amount by subtracting the 3 angles that we know from 180 to get our remaining amount of 45 degrees. And so we would know all of the pieces here in this image from all of those markings. Over here, we have a set of congruent angles. And we also have linear pairs. So I want us to focus on this as a linear pair right here and the bottom as a linear pair right here. Linear pairs are supplementary, which means that the top 2 angles are a supplementary pair and the bottom 2 angles are a supplementary pair. Since these angles on the left are supplementary to an angle pair that is congruent to each other, we are able to know then that these 2 angles are congruent as well through the congruent supplements theorem. So now we're able to at least know some matching pairs of angles. In this diagram, though, we are not able to determine what any of the angles are individually, but we are able to just use the linear pairs here and the congruent supplements theorem to identify the fact that the pair on the left would also be congruent to each other. So those are our angle pair notes, just kind of reviewing supplementary angles, complementary angles, vertical angles, linear pairs, and incorporating that into proofs.